Hey everybody, it's Mr. Simons. Let's look at our next lesson. So we're going to talk about lesson 3.1, which is on graphing linear functions. This starts about a 2-chapter unit where we're dealing a lot with linear functions and looking at different things with them, how to graph them, how to analyze them, how to work with them, just a lot to do with that. So let's get started. All right, so first thing we should probably talk about is what do we mean when we say linear function? Well, we're going to use more often the term linear equation. Function is it's kind of a broad term for it, but equation and function mean kind of the same thing. Basically, it's going to have, generally speaking, 2 variables, right? And the term linear, if you look at what I have written here, it says it's an equation that forms a line when it is graphed, all right? The clue to that is in the word linear, all right? Linear. First 4 letters, line, okay? So when you graph it, it makes a line. And when you write them, they write them in this form called standard form. And so standard form is this form where you have x and y, if both variables are present, are on the same side. Your a, your b, and your c are all integers. Okay, so no fractions, no decimals, and a is always positive. All right, it has to be 1 or greater. So pretty much if it's written in that form, then it's in standard form. One thing you'll notice is that the exponent by x and y is always going to be 1. So if you have anything where you have like a squared or a cubed or anything like that for an exponent on either variable, it's not a linear equation. The other thing you want to notice is that x and y are not next to each other. Like they're usually separated by an addition or a subtraction operator. So they're not multiplying by each other or dividing by each other. And so you're going to see some examples, non-examples of linear equations where they show you something like that, and that should be kind of a red flag. So let's kind of look at a few of these. All right, let's look at a couple examples. It says determine whether the equation's a linear equation and then write it in standard form if it is. All right. So we've got y equals 4 minus 3x. So I've got a y, I've got an x. Now you don't have to have both. You can have just one or the other, but you need at least one. So I've got both of them in this case. And so that's good. That ticks that box. Their exponents are 1. So that ticks that box. They're not multiplying by each other, so that's good. So yeah, it's a linear equation, so we'd say yes, it's a linear equation because it'll make a line if I graph it. And then what I'm going to do is I am going to take this and I'm going to work on putting this into standard form. And so the way I'm going to do that is recognize that I have to have the x and y on the same side as each other because you've got this ax plus by equals c, right? So, and we know that a has to be positive as well. So if that's the case, my x term right now is -3, and that's negative. So maybe what I should do is just move this over to the other side because then that puts them together and it makes my x term positive. So I'm going to add 3x to both sides, and you're going to get 3x plus y equals 4. I look at this and I go, okay, all of my coefficients are integers. My a coefficient is 3, b is 1, because there's nothing listed in front of the y, and my c is 4. So yeah, we're in good shape. That's in standard form, and we are good. All right, let's look at another one, another couple. So 1a, you got 1/3 y equals -1. Well, I know it's definitely not in standard form because there's a fraction there, but we want to see if it's linear first. I don't have an x term, but I do have a y term, so as long as you have one of them, you're in good shape. So yeah, so that's ticking that box. And then it's y is not multiplying by x. There's no x to multiply by. And its exponent is 1. So yeah, this is linear. So you would say yes, this is linear. And then if we're going to write it in standard form, what we got to do is we got to, first of all, get rid of that fraction. And so the way you can get rid of any fractions in any equation is just multiply by the common denominator. The common denominator is 3, right? So I'm going to multiply this whole thing by 3. So if I multiply 3 by 1/3 y, I just get y. And then if I multiply 3 by -1, I get -3. Right? I don't know why. I've been having lots of problems with this lately. All right, so my finished equation is y equals -3. And that is, believe it or not, in standard form, because my a, which is the coefficient in front of my x term, would be 0, which is why you don't see it. My b is 1, and then my c is -3. So there you go. All right, this next one right here, hopefully if you look at it, there should be something that jumps out at you on this. And to me, it's this squared, x squared. Well, I know that my exponents can't be greater than 1, and that 2 is greater than 1. So that would be a big no. You can't have a quadratic or a squared term in a linear equation, because this thing would make something that's more like a graph like this, right? And that's not what we want. We want a straight line. Okay, last example here. So if you look at this one, hopefully something else jumps out at you, and it should be this term right here. You've got x and y multiplying by each other. And because you have x and y multiplying by each other, that is not a linear equation. Because what would happen is if you tried to actually get everything combined, you would wind up with something in the denominator, a variable in the denominator. And whenever you have anything that's like this, all right, it gives you an exponential equation that kind of looks like that. And it's cool, but it's not linear. It does not make a line. So this would be another example of no. All right, moving on. Now, we're going to start talking a lot about x and y intercepts. So x and y intercepts are where the graph intercepts the x-axis and the y-axis. So the x-intercept is where the line crosses the x-axis, and the y-intercept is where the line crosses the y-axis. Pretty self-explanatory. On those, it doesn't matter where it crosses it. It's so if you have a general thing right here, so where that crosses right there, that would be the point whatever x is, and x always goes first, and then your y-coordinate would be 0. Your y-coordinate has to be 0 where it crosses the x-axis, because that's just what y is, if you think about that. All right, so this is my little x-axis here, this is my y-axis. For some reason this thing is not letting me write. Okay, and then my y-intercept is going to be right here, and that's going to be the point 0, y, you know, depending on what it is. So it has to be 0, because if you look at where it is in terms of x, and remember x is your direction this way, it's on that line, which is kind of like the fence between the positive and the negatives for x. So that's why it's 0. So this is an important idea to understand moving forward, because it will help us working with solving equations. So it says find the x and y intercepts of the line graph to the right. All right, so my x-intercept on this one is going to be this one right here, because that's the x-axis and that's where it crosses, right here. And so I would just write my point. So my point would be the point 20, 0, and that's my x-intercept. And then my y-intercept, I'm going to write int here. I don't know why I didn't do that for x. All right, my y-intercept is going to be where does this cross the y-axis? And it crosses the y-axis right up here. Okay, so I would look at that and say, okay, well, my x-coordinate at that point is 0, and my y-coordinate is 30. So that's my x and my y-intercept. Let's look at another example. It says find the x and y-intercepts of the graph below. So if we look at kind of like what this represents, it's gym membership at 0 months. your total cost is 150, but you'll notice that as the months go up, your cost stays the same. So this must be like a flat fee or something like that that you pay. So it doesn't matter if you go there for 1 month or 6 months, it's going to still cost you 150. We don't know what it does after this. We'll kind of assume it goes straight, but at some point you'd have to pay more, right? So for your x and your y-intercepts, let's start with our y-intercept because that's easy. That's right here because that's where it meets that y-axis. And it meets the y-axis at the point 0, 150. So 0 months, you pay 150. All right? Now for your x-intercept, this is kind of interesting because if you look at this line is running parallel with the x-axis. So your x-intercept, think about it. Is there ever going to be a moment after any number of months moving forward that you're going to, oh no, you're going to pay nothing? No, of course not, right? So that's the way that works. So what you'll do is you will say your x-intercept, it does not exist. So you could say none, right? And that works. It does not cross it. So this actually forms a line that would be y equals 150. So no matter what x is, so if x is 1, 2, 3, 4, right, y is always 150. And that looks kind of like one of those lines that we looked at before. All right, so now the last thing we're going to do today is we're going to look at how do we find x and y intercepts from other visual and equation forms. So this, I'm not going to spend a lot of time on this. This is a table. All you got to do when you look at a table is you're just looking at, for your x-intercept, you're going to look for the term, sorry, I don't know why this isn't working. You're going to look for the term where y is equal to 0. All right, so I'm going to look for that. And y equals 0 down here. All right, so for my x-intercept, I would have the point 14, 0. And that's where it crosses that. And then the y-intercept is going to be the point where x equals 0. Right, and we discussed this. And that would be right there. And so your y-intercept would be the point 0, 10,080. And then if you look at this and just want to understand kind of what this table means, it means that if you're going to drain a pool, when you start, it looks like your total number of gallons is 10,080 gallons, and then by the time you've been draining it for 14 hours, your volume is at 0 gallons, which means it takes 14 hours to drain your pool. All right, now we're going to find intercepts from equations. All right, so the thing is, we've been talking about how when you're finding your x-intercept, your y-coordinate is 0, and when you find your y-intercept, your x-coordinate is 0. So we're going to use that in this equation form to help us. So if we're going to find our x-intercept in this right here, okay, this would go a lot easier if my device would work right. So if we're going to find our x-intercept, what you're going to do is you're going to put 0 in for y, so right in there. So we're going to go 2x minus 5 times 0 equals 1. Well, 5 times 0 is 0, and it just basically gets rid of that point. So you're left with 2x equals 1, and then you would divide both sides by 2, and then you would get x equals 1/2. So my x-intercept is going to be the point 1/2, 0. All right, and then for your y-intercept, you're going to do the same thing, except you're going to make the x term 0. So you're going to go 2 times 0 minus 5y equals 1. All right, this goes away because anything times 0 is 0. You have negative 5y equals 1. We're going to divide both sides by negative 5 to get y by itself. And you'll get y equals negative 1/5. And so my y-intercept then is going to be the point 0, negative 1/5. All right, and those are kind of unfriendly numbers, but if you have a graph that's set up the right way, it should work out fine. All right, let's look at a couple more. All right, this one. All right, now it's not written in standard form, and so that kind of freaks a lot of people out, but you can still do this. All right, so I know that my x-intercept is going to be where y is equal to 0. All right, I'm going to put that right here, where y is equal to 0. So let's rewrite this, and wherever we see y, we're going to make that 0. So we have 1.25x plus 7.5 equals, and that's y, so we're going to put 0 there. So what that means is that whole right side is zeroed out. So at this point, this is a multi-step equation. So let's move 7.5 over to the other side. And that gives you 1.25. Or sorry, I put my decimal in the wrong place. That gives you 1.25x equals negative 7.5. We're going to divide both sides by 1.25. Okay. And 1.25, I believe, goes into 7.5, I want to say 6 times, I think. Yeah, 6 times, all right? So you had x equals negative 6 because you have negative divided by positive. So my x-intercept is going to be the point negative 6, 0. Right? So if we were looking at a graph, that means I'm going to have a point like over here somewhere. And then for your y-intercept, you're going to make x 0. So you're going to go 1.25 times 0 plus 7.5 equals y. And this one works out really nice because when this goes away, you're left just with this, 7.5 equals y. So you're done. So that means your y-intercept is the point 0, 7.5. So you would go on your graph, and that would be about here if I scale it out. And then you'd connect your 2 points. And that's how you find your intercepts using equations. Okay, for your x-intercept, you make y equal to 0, and then see what happens with it. And then for your y-intercept, you make x equal to 0. So you're just plugging in 0 values, and I think that helps you understand that better. So good luck with these, and we'll see you soon.